I never would have imagined conducting botany field trips online. It's a radical departure of the way we typically do things. We're going to do our best to try and mimic what a field trip would actually be like, and more importantly, accomplishing the same kinds of things. And I think we can do that sort of anyway. We'll do the best we can. Just to give you some idea of just how different this semester is going to be. Typically this class, half of the class time, a full half of the class time is spent out in the field, actually looking at plants, long 4-hour field trips. And in fact, of the remaining half of the class, almost half of that is spent doing lab things. Students are working through their plant collections and identifying them. So trying to convert lab and field experiences to an online format has been really, really challenging, I have to say. I hope we're at least partially successful at this. I'm also not sure if this is going to be our first field trip. Sam Doty, one of the other instructors for the course, is also working on a kind of an early season field trip down in Washington County where things tend to come out a little bit earlier. So we may decide to run his first. So this might actually be your second field trip. But at this point, still late April, I don't know for sure. To give you an idea of where we'll be going for this field trip, you can see it's Santaquin Canyon. Many of you, I suspect, have no idea where Santaquin Canyon is. In fact, I grew up in Provo, and I didn't know where Santaquin Canyon was until I moved down kind of in this direction. I don't live in Santaquin, but just a little bit north of it. Here's a map to orient you a bit. You can see Santaquin up in the upper left. And then in the red square is the section of Santaquin Canyon where we'll be looking. And on the right is a blow-up of that red square, so you can still see a little bit more closely. So what I'll be doing is walking up the canyon for maybe a mile, maybe just a touch more than that, and then back down, and we'll be looking at plants and other things, always on field trips as we're sort of walking along looking for the next thing we need to look at. We comment on all kinds of things, the rocks, the cliffs, it's a beautiful day, those kinds of things. And there'll be a little of that in our field trip as well. Well, this is my first stab at a virtual botany field trip. I'm feeling very inadequate at the moment. And I hope you're not expecting anything too professional. But I think we can pretty much mimic the way things would work in a real field trip, which is we'd all come to a particular location, we'd wander around, and we'd look at plants as we encounter them. And so I'm going to try and accomplish the same thing virtually this morning. I'm up Santaquin Canyon. For those of you that may not be, I'll scan a little bit so you can get a look at the canyon. For those of you that may not be familiar with it, it's a beautiful, beautiful area. As the name suggests, just out of the town of Santaquin in the southern part of the valley. It's a gem, really. It's a very underutilized one as well. I grew up in Provo, and I didn't know that Santaquin Canyon existed until I bought a house not too far away from here. Anyway, it's a beautiful little spot, and we're going to see what we can find in the lower part of the canyon. It's still very early. Today's just the 24th of April, kind of getting an early start in all of this so we can catch some of the early spring blooming plants. Due to fires, really terrible fires, a year or so ago that affected both Payson Canyon and Santaquin Canyon, runoff, because there were no trees left to hold the water back, caused massive damage to the road. We won't get up to the worst parts of it today probably, but this road has been closed for a year or so now due to the road damage and danger from landslides and things due to that fire. Okay, we're going to walk up here just a little bit now. One of the reasons that I really love this spot in particular is because we have some beautiful, beautiful spring flowers here. And I want to find a particularly good patch of them before we pull over and take a look at them. So we're just going to wander up this road a bit. You can see, I'm going to scan over this way just a little bit. You can see that things are really starting to bloom now up here. And in fact, this plant that you see, the green in the image, is one of the first ones we want to take a look at. But I'm going to find a little bit better patch. This one's kind of past its prime now. Okay, this is probably a good spot. One of the real disadvantages of coming out early for a field trip is I won't really know what we've discussed in class prior to this field trip. So I won't make too many assumptions here, but there are a couple of things I'd like to point out about the plant. And I'll try and get my finger over here to point these out to you. But first of all, look at the number of perianth parts. Remember, the perianth includes both the calyx and the corolla. And one of the things you probably notice immediately is there's no differentiation here. In other words, all of these parts, and you can probably count them in the image, but there are 6 of them, they look the same. So they're not clearly differentiated into calyx and corolla. And the term we sometimes use for this is tepals, just to refer to the perianth parts collectively when they're more or less the same. They all look kind of like petals. I am going to give you the common name of this plant. I really like it. It has a couple of different common names. We're not going to talk about the scientific name yet because a little bit later we're going to dissect one of these flowers and we'll work through it together and key it out. But the common name, my favorite common name, is dogtooth violet. And you can see the reason for the dogtooth name. Look at the tooth-like nature of these. They tend to curl back upon themselves. In fact, let me show you another one here, maybe a little bit closer up. And like the teeth of a dog or something like that. The other name for it, by the way, violet, dogtooth violet is not the greatest name, even though I happen to like it, in that it's not a violet, and instead it's in a totally different family. This thing, the other name for it is glacier lily, which is a more appropriate name, frankly, because it is a member of the lily family. And as I said, we're going to work through this a little bit later and work through a key and figure out precisely what it is, the scientific name. But boy, is it a gorgeous plant. Every year near the mouth of Santaquin Canyon, these things come out in mass, as you're seeing here today. It's just a wonderful time to visit the canyon. These plants come up from a bulb, and they're all over the mountains, from low elevation to high elevations. And they bloom progressively. So right now, in third week of April, they're blooming at the low elevations. In fact, at the very lowest elevations, they're kind of past their prime. But that will continue upward. Almost immediately after the snow melts, these things emerge and flower very, very quickly. And so at high elevations, it might be August before these things are out. So they make this march up the mountainside from low elevations to high as the season progresses. By the way, one of the reasons they're called glacier lilies is because of the fact that the snow is scarcely gone in the springtime before these things start popping up. One of our really pretty early spring wildflowers in the local mountains. Okay, continuing on up the road a ways, I do see a plant that we need to take a closer look at. It's right over here. This plant, I'd like you to notice a couple things. I'm not going to set this on a tripod right now, try and hand hold it, but there are a couple of really interesting things about it. First off, look at the nature of the leaves. And I'm going to reach over, sorry, I'm going to jiggle this, but I'm going to reach over and grab one leaf, and believe it or not, let me set it down so I can get a better image of it. what you're looking at is a single leaf. Let me get in a little bit closer. Sorry, I'm not much of a videographer. Okay, that structure is a single leaf. And you can see that it's highly divided, in fact, repeatedly divided. Look at how, sorry, I'm trying to do this without jiggling too much, but notice how there's one branch that comes off, and of course, not a number of them, but then each of those branches subsequently branches again, and in some cases yet again. So this is a great example of a compound leaf, and in fact it's a multiply compound leaf in that the leaflets are also divided into segments. Okay, let's take a look at the reproductive part of this flower. It's actually past first full flower right now. Let's see if we can get that focused. There we go. This is the inflorescence of the plant, in other words, the blooming part of the plant. And one of the striking things about this is the arrangement of flowers and flower parts. I'm going to turn this over so you can see it a little bit better. In fact, I think I'll pluck it. Let me get that. There we go. Notice how all the branches of this inflorescence are arising from a common point. And then once again, subsequently, they split again from a common point. This particular type of inflorescence is called an umbel, and it's a characteristic of this family, which is called the umbelliferae, or the alternative name is the Apiaceae. But this is one of our musno families, but remember that this is a group B family. And what that means is, I don't expect you to key these out. They tend to be quite a difficult group to key out. You probably need to gain a little more experience before you try it. And we have a big enough job trying to learn how to key out the things that are a little bit more straightforward. But this is a group B musno family. They have 5 of these. And these are things that are so distinctive that you really should be able to recognize them on sight, and I'll expect you to, but not because of keying. You don't need to know floral formulae or anything like that for these plants. So how are you going to recognize it? Well, the 2 major things that I would suggest is the nature of the inflorescence first, that we just discussed, this umbel inflorescence that gives the family the name umbelliferae, which helps you remember it. And the other thing, of course, are these compound leaves. In many cases, multiply compound leaves. If you see that combination of traits, you're almost certainly dealing with the umbelliferae. Okay, continuing on up the road a ways, we'll see what else we can find. Let's get over here where we have a little soil we can look at. Aha, there's another one we can glance at just real quickly. Take a look at this little plant. That should look kind of familiar to you. In fact, you ought to be able to make a reasonable stab at what this thing is. First off, look at the nature of the inflorescence. I'll try and zoom in on it a little bit. Does this look familiar to what we just looked at? Notice the umbel-like shape. In fact, I'll turn that upside down so you can see it a little better. Okay, where am I here? Try and find it now. There we go. But you can see the umbel-like arrangement of the flowers, and notice the leaves. They're kind of a, oh, there's a good one. I'll try and get a picture of this one. Notice the compound nature of the leaves. We're looking at a single leaf again in this case. So anyway, obviously then this is another member of the umbelliferae. It's a common family. In fact, we'll probably see more representatives of it as we continue on up the canyon. We just looked at this plant a moment ago, but I have to take another shot of this because this one's a little bit farther along and really shows the umbel inflorescence very, very well as of course the compound leaves. So once again, the umbelliferae, or the Apiaceae is the alternative name, and you can use whichever one you'd like. Both are perfectly acceptable. Okay, let's continue up a ways. Okay, this is the stream in the bottom. I'm not sure I caught the cliffs. Maybe I'll have to back up. Anyway, notice that it's starting to get kind of muddy. I was up here 2 days ago, maybe 3, and it was just running crystal clear. So what that is telling me is that now that the weather's warmed just a little bit the last couple of days, we're starting to see spring runoff beginning. And I do mean beginning because this will be a raging torrent when it's in full melt mode. So we're just getting a good start on early spring here. Some of the scenery in Santaquin Canyon, just really a remarkable place. Some of these folded layers near the mouth of the canyon are just fantastic, as well as some of the bedding plains that appear as that real sharp, flat section of the cliffs there. This is a striking canyon that I can't recommend highly enough. It's just beautiful up here. I only wish that we could all be up here in person. All right, let's go farther up the road and see what we can find. There aren't a lot of things in bloom yet, but they are getting a start now, which is nice to see. Even the leaves coming out on the oak trees and things are really beautiful right now, especially in this early morning light. Beautiful sight up here. Okay, I can see a plant that I do want to stop at. It's one we've already seen, but I keep coming to better examples of it. All right, if you had any question about what I meant by an umbel, this should help. Take a look at that beautiful umbel inflorescence. And of course you can see the multiply compound leaves as well. So clearly an umbellifery. In fact, we did see this one lower, it just wasn't as far along. Our focus is not on woody plants in this class, although you're welcome to include woody plants in your collection if they're flowering. And we're here so early, the trees are just barely starting to leaf out. But these are big-tooth maple, quite a nice stand of them here. And I do want to talk a little bit about the community. We're in a kind of a mountain brush community here, and big-tooth maple is a characteristic member of that plant community. You can see it all along the roadsides. Then you can see some conifers as well. This is a white fir, which is also very, very common here, but I'm going to pan up a little bit onto the hillside, and you can see that there are more than one type of conifer in the canyon. Lots of Douglas fir, lots of white fir, with some spruces here and there. But we're kind of at the lower end of their elevational range. And this is really more mid to low elevations, at least as far as mountains go. And because we're along a stream side, this is also a riparian community. So we have cottonwoods, they're the tall trees that you see there. And all of the various things that are water loving and need large amounts of water would be found along the riverbank. We may encounter some a little farther out. Well, this seems to be an umbel day today. I noticed another one. We'll take a quick look at it. You can see if it'll find focus here. Come on, maybe I'm a little too close. There we go. You can see the umbel inflorescence quite nicely here. Let me see if I can get a little bit closer to it, in fact. And it's still quite young. You're probably having trouble seeing the rays of the inflorescence. But look how highly dissected these leaves are, even much more so than what we've seen up to this point. Clearly an umbel. All right, I see another plant that we need to stop and take a look at. It's right over here along the side of the road. It's a very pretty little flower. In fact, I'm going to set the tripod up so we can get a closer look at it. This is also one of our common spring blooming flowers. The common name that's most often applied to this family is waterleaf. And I think this is one that we're going to take a closer look at, maybe dissect some flowers and perhaps try keying it out as well. But let me give you a little bit closer look at it. Okay, one of the things you'll notice, I'm going to grab a little stick here maybe to use as a pointer. Notice how the stamens are actually extending out considerably from the corolla. Just one of the things that makes these flowers look very delicate, very pretty. And then the dark anthers on them helps as well. Anyway, I'm going to collect a little bit of this, and a little later we'll dissect a flower and see if we can key it out and learn its scientific name, at least a genus. We're coming to a little bit more open area of the canyon where a little bit more light comes through, especially on these south-facing slopes of the canyon. And as a result, the vegetation is considerably distant here, much drier vegetation. This is a juniper, a Rocky Mountain juniper in this case. And over here to the left is what's called curl-leaf mountain mahogany. I'll get a little bit closer so you can see what the leaves look like. Once again, these are not really the focus of our class. This thing is in bud right now, but a very, very important range plant on our foothills and things. During the winter time, this is one of the staple food sources for deer and elk and things. Kind of a pretty plant. When it's in flower, it's really gorgeous, as a matter of fact, but typical of drier areas in our mountains. In this section where there's a little bit more sunlight, some of the plants are a little bit more advanced than what we've seen down below. And I want to point out the flowers on this big-tooth maple. This plant is in full flower. I know that doesn't look too impressive because they don't look much like flowers, but this is the nature of flowers in wind-pollinated species. They have no corolla. No need for a corolla. You're not going to attract the wind after all. And what you're seeing, the reddish stuff you're seeing, is groups of stamens dangling down, ready to release their pollen as soon as the breeze comes up and carry it to a female plant, female flower. Taking it on a side again, a little bit from botany. I hope you can hear me over that stream. But this gives you some idea of the damage that occurred after the big, huge fire we had a year or so ago. And you can see that tons of material has been completely ripped from the banks of this stream and carried downstream. Great big boulders that have fallen from the roadway, or just below the roadway, down to near the river. You can see piles of dead trees and driftwood as they pan up the canyon as well. Really took its toll on this canyon. Another very prominent outcrop here. And we're going to look at some more damage from the flood just up above. And in fact, the reason this section of the road is closed. Some of you may find this kind of interesting. Along the side of the road, this is a Rocky Mountain juniper, and I was about to say it's in full flower, which is absolutely not true. These don't produce flowers, but rather cones. But this is a male individual, and the cones are absolutely ripe right now and releasing pollen. This is a wind-pollinated species, so the pollen, it just waits for a little breeze, and then it will kick up and release the pollen. But just to give you an idea, I'm going to back out here just a little ways. But let me tap on one of these branches and let's see if we can see the pollen. Yeah, I think you could see that. Clouds of it coming off right now anytime the breeze picks up. And of course the pollen grains from these little temporary male cones are hoping to find a female cone somewhere and fertilize the eggs, and the seeds of course would develop then in female cones, what are things we call juniper berries, in reality a cone. There's a good example of the female cones. As I said, we often refer to these as juniper berries, but a berry is a fruit type, so it's really a misnomer. These are actually little squatty female cones with the bracts kind of somewhat fused. We're coming now to one of the most damaged areas of the road, at least on this lower section, and this is clearly the reason for the road closure to vehicles. You can see the, well, as I get a little closer anyway, you'll see the red warning paint that's been put down on the road so that people don't get too close to this edge. But you can see how the stream bank has just been scoured out by the flooding and undercut the road, essentially. I'm going to go around to the other side and see if I can get, well, maybe this is as good. But you can see how that road has actually been undercut by flooding, so that if a car were to come close to this, very easily could break off and cause a real catastrophe. So the road's going to stay closed for a while. They do have plans to repair the road. By the way, this is nothing compared to what's up a little higher in the canyon, where the entire road is gone. It's just a bouldery mess in its place. Federal government is planning to do some repair work this summer in June, or they were before the coronavirus. I'm not sure how that will impact things. And that may extend into summer of 2021 as well. It's just a real mess up here. The bright side is that you can walk up here now and kind of have the place to yourself. It's much quieter than it would otherwise be. Here's a much better view. And get a little closer here of those maple flowers. You can see those red anthers hanging down from the stamens, ready to release their pollen. At this point, the canyon narrows down. The cliffs become closer on both sides, and as a result, it's a much shadier environment as well. You can see the cliffs over on this drier side a bit. But one of the things I'd like to point out is, you know, one of the things we're learning about in this class, or will, is about plant communities and the different types of species you would expect to find in various communities. And what we'll learn is that most of the time the community is controlled largely by elevation. And of course elevation also determines things like temperature and moisture availability. So those are the actual driving factors, but they're correlated with, of course, with elevation. And right now, as we enter this little bit shadier area, one thing to note about elevation is that it's not a hard, fast line. You don't see like topographic rings around areas at all, but rather it has to do with microenvironment and aspect. In other words, the direction of the slope and those kinds of things, which also control moisture availability. In this case, what we're seeing is some spruce fir forest that's kind of fingered down below where it would be dominant, typically, and it's due to the shade, which is providing more moisture and cooler temperatures. And so this is a very nice stand we're walking through of white fir, Douglas fir here and there as well. Haven't noticed spruce right here, but there's undoubtedly some here too. once again, take a look at the damage that's being done by the floods caused by loss of vegetation due to our fires. Take a look at the roots of these trees. That one doesn't have much longer to last before it's completely undercut and collapses. You can see one out in the middle of the stream. In this case, it's a dead tree, but it's not going to be upright long either. It's rapidly being undercut by spring runoff. We've reached Trumboldt picnic area. You can see a little footbridge that goes across, a little piece of abstract artwork. And if you were to follow this bridge and go down just a little bit, we're not going to be able to see it in this footage, but there are group areas with a whole bunch of tables where families can get together and things. It's a very, very nice spot. There are more scattered tables as well for smaller groups or couples or whatever. It's a beautiful, beautiful area that's used fairly lightly for the most part. If you're here at very popular times, it can get busy. But a great resource. Right now, the only way to access it is by foot. And as a result, it'll be very quiet, beautiful place to come for those who want to pack a lunch and come up and enjoy the stream and the scenery. Anyway, recommend it. We're also coming to the end of our field trip, at least as far as the places we're going to go to. We passed the first gate when we began. There are two gates in the canyon, and we're coming to the second now. The first gate is closed to vehicular traffic, but foot traffic is welcome. However, that changes when we get to this second gate. Much more dire conditions up a little farther up. In fact, they've posted some pictures, and I want to let you see these. I think I'll turn this off till I get a little closer. As we get a little closer to this gate, notice the scenery in the canyon. This is where it really starts to narrow down and the cliffs become very, very dramatic. I'm afraid you're going to have to wait for another year if you're interested to come up here, because this won't be open for a while. And in this case, it's not just closed to vehicles, but also even to foot traffic. It's just considered to be too dangerous up above due to rock slides and mudslides and the fact that there is no road remaining any longer. In fact, let me show you a couple of pictures they've posted of some of the damage. See if I can get that to focus. There we go. You can see a person standing on that log. And this is where the road once was. It's completely washed out. The same is true in the picture below. You're looking at the road bed. So it's going to be a while and take tons of money to get it repaired. In the meantime, the area remains closed, and we're going to respect the signs. We're not going to go any higher than this. But once the road opens, please come up and see the place. It's well worth your time. Okay, from here, we're going to head back down the canyon. By the way, if this had been a normal field trip, we would have parked down at the first gate and all walked up to this point. And because we would have been looking at plants all the way, it probably would have taken us 2 hours to reach this point. And because I've been turning the camera off here and there, we've shortened that dramatically. So in one way, we're going to condense what would have been a 4-hour field trip into maybe a couple of hours by the time we do our flower dissections and keying. So we do get a little more botany in probably. I am going to wander across this second footbridge for just a moment in Trumboldt, because there are some understory plants over here that I want to mention just quickly. They're not our focus in the class, but they're kind of interesting. This bridge was put in just a few years ago, or the old one was replaced, I should say. It used to be an old rickety thing. One of the things I want to show you, though, is this little plant right here. has a great name, one of the prettiest plant names I'm aware of. It's called Mountain Lover, and it's in full flower right now. It's from a very odd little family that's not well represented in Utah, called the Celastraceae, and we're not going to be keying this out. It's not a must-know family, but it gives you some sense of botanical diversity. This plant is common in spruce fir forests, sometimes in aspen forests, all throughout our local mountains. It's one you can hardly miss. And I'm going to grab a sprig. We're going to look at the flowers up close a little later under a dissecting scope. Another one that we see really often, and this isn't in flower, although some of them are up here, and this is called Oregon grape, which is really not the greatest name for it because there's another plant that's more properly called that. Creeping Mahonia is another name for it, but it produces clusters of yellow flowers this time of year. I'll try and get some footage if I see one in flower. And then later in the season, clumps of dark blue, almost blue-black berries that are actually edible. Another very, very common understory plant in mountain brush communities, but also in spruce fir communities like we're in now. Heading down, I've wandered off the trail just a little bit, see if we can find some things I didn't notice along the road. And what I'm in right now is a burned area, and this is not from our recent burn. This is a fire. It was a devastating fire, but this occurred, I don't know, 8 to 10 years ago maybe, something along those lines anyway, and cleared out mature trees through this area that we're seeing. And although they haven't leafed out yet, most of what we're seeing, or much of what we're seeing, is elderberry. This is, in fact, a great place to come and pick elderberries, which are edible and make good pies and jellies and jams and that kind of thing. I'm going to pan across to the other side of the canyon where you can still see the dead standing trees from that fire a number of years ago. And it just wiped out the trees all along these hillsides, again leaving nothing to hold soil back, so that you can see the dead trees beginning to fall and inevitably ending up in the stream and being carried down in high water years. I do notice one really, really pretty wildflower, early spring wildflower here, and we're going to walk up and take a little bit closer look at it. This happens to be a member of one of our must-know Group A families, in other words, one that you need to know a floral formula for and be able to recognize on sight. But look at this beautiful patch of blue flowers. I'm going to set this on a tripod so we can get a little better look at it. I mentioned that this is one of our 10 must-know families, our Group A families, and we are going to do a dissection of this flower a little bit later in this video. And the flowers are small enough, I'm going to do this under a dissecting scope so that we can see detail a little better. But in the meantime, let me zoom in on this. And I'll give you the common name for this. These are called bluebells. And as I said, they're one of our early spring flowering plants, and another one that kind of marches up in elevation as the season progresses. But very, very pretty. And in this particular location, there are lots and lots of them. They seem to be liking the sunlight. I'll see if I can pan over here just a little bit to give you a better feel for that. And see, they're all over up here. Very pretty flowers. One of the things I will point out now about them is that the petals are united. So in other words, the corolla is one structure. The petals are fused together in this case, which is one of the distinguishing characteristics of this family. But more about that later when we dissect. Also in this little bit sunnier area, the Oregon grape, the creeping Mahonia, is really coming along, and it's in full flower in this part of the canyon, as you can see. Let me zoom in on one. Very pretty, pretty plant. By the way, these are evergreens, so those leaves stay all year.
Now, having said that, you can see that some of them have turned red. And being evergreen doesn't mean that you never lose your leaves, just that you don't do it seasonally. So these probably are dying, new ones will come. And the leaves were quite stiff. You can see the little spines along the edges of them probably. Pretty plant, couldn't be more common in our local mountains. We're approaching the end of our walk. We're getting down to the gate where we began. And so from here we're going to take a look at the flowers close up.
Now we're going to take a closer look at some of the plants we saw up the canyon. I collected little samples of each of them and brought them home again. And I thought before we begin, I'd show you my little work studio here. It's been very, very odd working from home. What I've done is taken a spare bedroom that no one is using in our house currently and set it up as a little studio. So on the left is a tripod with a camera and macro lens and the light set up. And then on the right, for really small things, a dissecting scope. And I've hooked a little mound onto it that will allow me to use a cell phone camera to take pictures. So this makes it much easier to see the details than trying to do this in the field. So what we're going to do now for the next little bit is work through some of the plants we found, go through the keys. Well, first we'll build floral formulae for each of them, and then work through the keys and see if we can figure out what they are. This one, you may recall, is referred to as dogtooth violet. At least that's one of its common names. So we'll start with this one and work through the keys and figure out what the scientific name is. Sometimes there are aspects of the plant that are really difficult to show. And in those cases, I'll just give you the information so that we can kind of make progress. First thing to know about this one is that it arises from a bulb. A bulb is actually an underground stem, food storage structure, and it'll have little tiny roots that will come off that bulb at the base, but the bulb itself is a modified stem. All right, so let's see if we can build a floral formula, but there is one thing we need to do first, and that is we want to determine whether this is a monocot or a dicot. And we've talked about this in class, the 4 or 5 things that we can look at to make that determination. First off, if you look at the perianth parts, remember the word perianth is a collective term for both the calyx and corolla. And in this case, since the calyx and corolla are not well differentiated, perianth is a real handy word. But there are 6 parts. You can probably see them in the photograph, but you certainly could in the footage from up the canyon. Another thing is if we count the stamen number, that may be difficult to do in this photograph, but there are 6 stamens. And if we look at the leaves, the leaf venation, in other words, the veins in the leaf, run parallel to one another. And that's a little bit difficult to see in this leaf because it's almost approaching a fleshy feel to it. So it's kind of a thick leaf, and the veins are embedded in that leaf tissue and not at all prominent, but they are parallel as well. So the question becomes, is this plant a monocot or a dicot? And if you remember the things that distinguish monocots and dicots, there's no question about it. Parts in 3s and 6s mean monocot almost always, and parallel leaf venation as well. So it is a monocot. All right, now let's build a floral formula for it. This is a photograph of one flower, the underside of the flower. I've broken the stalk of the flower off so it'll spread a little better. And one of the things you notice is you can now see the 6 perianth parts really well. But one of the things you notice is that 3 of those perianth parts lie outside of the other 3. And so we have outer parts and inner parts. And these correspond basically to the calyx and the corolla. In this case, they look alike. The sepals are said to be petaloid because they're petal-like, which is what that word means. So we could do one of 2 things. We could refer to all of these collectively as tepals. It's kind of the the term that's sometimes used when you can't really readily distinguish sepals from petals. But I'm going to stick with sepals and petals simply because based on position we can distinguish them. So obviously we have 3 of each. All right, I'm going to build the floral formula down in the lower right-hand corner of your screen so we can begin with the calyx. It's made of 3 parts, hence that superscript 3. Likewise, just as obviously, if we consider the inner perianth parts to be petals, there are 3 of those as well. So we finished with the vegetative whorls of the flower that constitute the perianth. 3 sepals, 3 petals. All right, moving inward now, the next thing we need to do is look at the andrecium and see how many stamens there are. This is a little misleading in this photograph because the 2 back stamens are still fairly young and fresh. They're still probably releasing pollen. And the ones in the foreground are old withered anthers that have already lost their pollen and have kind of shrunk a bit. But nonetheless, if we count them, there are indeed 6 of them. So we can add that to our floral formula down in the lower right. All right, that just leaves us one thing left to do. Actually 2 things, but one main thing, and that's to look at the gynecium. These are the female reproductive parts. What I've done in this case is I've removed a couple of the petals and a couple of the stamens so that we can see inside the flower. And there are 2 questions we need to answer, and they're both posed here. Is this a superior or an inferior ovary? And how many carpels are there in this pistil? So let's start with the first of the 2 questions. Is this a superior or an inferior ovary? Well, now I've labeled the stigma, the style, and the ovary. And looking at this ovary, first thing you notice is that it's readily visible. There's nothing fused to it at all. It's kind of up and obvious. If you look at the ultimate point of attachment of the filaments on our stamens, they go clear down to the base and attach below that ovary. And the same is true of the sepals and petals. And so what is the answer then? I'm hoping most of you jumped on this really quickly because all of these are features of a superior ovary. In other words, the ovary is superior to the other parts. It attaches above the other parts attach below it. So we can add the G for gynecium with a line underneath it to indicate a superior ovary. The next question is, how many carpels make up this pistil? You may recall I gave you about 4 things to look at to determine carpel number in a pistil. And I recommend always starting with the ones that are easiest to see and working from there. Remember, our general rule is if you look at the easiest thing and there's only one, you go on to the second easiest. And if there's more than one, you're done. But if there's one of those, then you move on to the third easiest and so on. So what you're looking for is a number greater than 1. By the way, if you get clear through this process and you find no numbers greater than 1, it means that that pistil is composed of a single carpel. Okay, let's go through the process. Let's start with styles. They're typically the easiest. And as you look at this photograph, there's only one style. So let's go to the second easiest, which is stigma lobes or stigma branches. And I think you can see pretty clearly that there are 3 stigma lobes in this particular case. So we're done. That tells us that there are 3 carpels that make up this single pistil. So let's add that superscript. And notice the circle around the 3, that whenever parts are joined together, fused together, you put a circle around the number. So that circle around the 3 indicates that we have 3 carpels, but they're united into a single pistil. All right, the last part of this, and it would usually be shown underneath, you usually draw a line and then put it underneath, but to save space, I'm going to put it to the side. And that's fruit type. These are way, way too young to see fruits yet, so that's something we can't determine. But when it does produce fruit, that fruit will be a capsule. So we have our floral formula finished. By the way, I just want to put in another plug for floral formulae. As a student, this is exactly what I would do. And that is, when you're trying to key out a flower, don't just jump directly into the keys. Look through it, dissect it, build a floral formula, And then from that floral formula, the keying becomes much more straightforward. You're not having to constantly stop and go back and check things and so on. All right, so let's jump into the key. And here we're going to begin with the key that I posted for you under the files link on Canvas. It's called Key to Families. It's several pages long. I strongly suggest printing it out. You're going to be using this a lot during the course, and you might as well have a hard copy you can refer to. And we're going to start right on page 1 at the top of the page. All right, so first thing, ovules not enclosed in an ovary, seeds in a cone, trees and shrubs. None of this is looking good, is it? Leaves mostly scale-like or needle-like and evergreen. Plants lacking true flowers and fruits. None of that sounds like our plant. Lead B of couplet 1 says, ovules enclosed in an ovary which ripens into a fruit, herbs, ours is herbaceous, vines, shrubs, and trees, leaves mostly broader and deciduous, plant producing true flowers and fruits. That sounds right. And so we've identified this as a member of the division Magnoliophyta. In botany, in the plant kingdom, we call the second level down below a kingdom a division for some reason instead of a phylum, but it's the equivalent. The division Magnoliophyta includes anything with a flower, so all flowering plants would fall here. Sends us on to number 2. Flower parts mostly in 4s or 5s, leaves mostly net-veined, roots generally in a taproot system. Well, again, none of that sounds right for our plant. Let's look at lead 2b. Flower parts mostly in 3s or 6s, that sounds good. Leaves mostly parallel veined, so does that. We didn't look at the roots, but they are little fibrous roots coming off of the bulb. So class Liliopsida. These are the monocots. Monocots are far less common than dicots, so most of the time, the things that you are going to be keying out will probably be dicots, and after you've keyed things out a time or two, you won't even bother with this part of the key. You'll go directly to the appropriate section, monocots or dicots. All right, Liliopsida. The monocots are toward the very back of our key, so if you're following along on a hard copy, we're going to go to page 13 now. All right, so key to monocots. 1A, plant body small, flat, and thallus-like, not differentiated into stem and leaves. Well, we saw good leaves. We know there are stems. And it's certainly not free-floating. 1B, plant body not necessarily small or flat and thallus-like, differentiated into well-defined stem and leaves, sometimes aquatic, but usually not freely floating. Ours isn't even aquatic, it's a terrestrial plant, so we definitely want to take the second lead. That takes us to 2. Perianth, at least the inner whorl, petaloid, and usually conspicuous. Remember that term petaloid means petal-like, and that's certainly true of these. In fact, both the inner and the outer whorl are petaloid. This other alternative says perianth lacking or inconspicuous, which is certainly not the case here. So let's go on to number 3. 3A, pistils several per flower. We can probably stop right there because our flower only had a single pistil. So let's go to the second one, pistil 1 per flower, and that takes us to 4. Fertile stamens 3 or less, flowers irregular or regular. Well, we had 6 fertile stamens, which fits 4B much better, and our flowers are regular. More about that a little bit later today. So we go to number 6, ovary superior or inferior. Well, just glancing down at our floral formula in the lower right-hand corner, remember that underline under the G means this is a superior ovary. So we now have our family, the Liliaceae. And now we're ready to move to the other little book to finish keying. By the way, before we start, we're going to be moving to the little spiral-bound book, Flora of the Central Wasatch. And before we pick it up, I just wanted to mention that the key that we've been using, the key to families, is one that I wrote, but the little book has its own family key up towards the front. And it's similar in many ways. I happen to like my own better. That's the reason I have a separate key to families. But if you're ever in a pickle, if you don't have your other key around, you can key to family with this little book as well. Also, something about the arrangement of the book. It's arranged alphabetically by family. Dicots in the front portion of the book and monocots in the back portion of the book. So Liliaceae occurs on page 87, so that's where we're going. All right, let's start keying. And what we're doing now is we're trying to figure out the genus that this plant belongs to. So this is a key to the genera within the family Liliaceae. All right, one says leaves small. Oh, by the way, one thing before we start. We talked in class about identification keys, dichotomous keys, and I told you about both bracketed keys and indented keys. And when you look at this key, it appears to be both. In reality, it's not. It's a perfectly good bracketed key, but the author, who's now a retired botany professor from Weber State, decided to indent every other couplet just so you could pick them out easily. But it's a perfectly good bracketed key. All right, let's go up to number one. Leaves small, filiform, or scale-like. Filiform would mean kind of thread-like. Leaves various but never filiform or scale-like. Well, look at the picture on the right. Those certainly not thread-like. They're not scale-like. They're perfectly good leaves. So let's go on to number two. Sepals conspicuously different in size, shape, and color from the petals. Well, that's not true at all, is it? We discovered that the sepals and petals are very, very similar. In fact, the only way we can distinguish them is by position. So the second two says sepals and petals similar or nearly so. That certainly fits our plant. So let's go to three. Plants without bulbs or corms, but with a definite, although sometimes tuberous rootstock. And as I mentioned, this plant does arise from a bulb. So the second three is our best bet. Plants with bulbs or corms. Down to six. Styles 3 or styles 1. Well, when we were carefully looking at the flower, we found a single style. So let's go on to number 7. Plants with leafy stems or plants without leafy stems, leaves basal. And if you look at the photograph over there on the right, notice that on the stalk below the flower, there are no leaves at all. In fact, this isn't really a true stem at all. It's what's called a scape. And it's really just a stalk to the flower. The leaves are all basal in this case. So we want to take that choice. The leaves definitely basal. That takes us on to number 8. Flowers in umbellate or subumbellate clusters. We saw some umbellate clusters up Santaquin Canyon. This certainly doesn't look like that. Flowers are not in umbellate clusters. They're borne singly, solitary. So down to 10. Flower, now it gets easy. Flowers yellow or bluish purple. Since they're yellow, it tells us the genus this plant belongs to is the genus Erythronium. All right, so what we would do next then is the genera are listed alphabetically within the family. And so we'd want to look down below this key alphabetically to find Erythronium. And it's on the same page as I recall. In any case, in this case, if you look down a ways alphabetically, you see Erythronium grandiflorum, and there is no further key. And the reason being that for this genus, we only have one species in our area within that genus. And so we're done. Our answer is this is Erythronium grandiflorum. So that's basically how we'd key. By the way, I have to say I'm not quite sure where this field trip is going to fit in. In fact, it may not even be our first trip. Sam Doty has been working on one down in Washington County, and that we may actually run that one first. So not knowing that, I've kind of meticulously worked through every detail. In the future, we won't need to go into quite that much detail. You'll be more familiar with how this is all done. Okay, let's take a look at some of the other things we saw up the canyon. First, we saw several members of the umbellifery, and remember this has an alternative name. You could call it the Apiaceae if you'd like, either are correct. And even from this single photograph, it's quite obvious what family this belongs to. But let me get in just a little bit closer. If I pluck off one of those heads and turn it upside down so that we can see it, think of the word umbrella and how all of the struts from an umbrella radiate from a common point in the center and then, of course, support the fabric of the umbrella. So if I draw some little red lines, it may be helpful. This is our primary umbellate branch point right here. And of course, it's upside down from what an umbrella would look like, but I think you can see the resemblance and the commonality of that word, the umbel part of umbellifery. In this case, each of those branches of the umbel branches again in an umbellate fashion. And this isn't at all uncommon in the family. In fact, sometimes it can go on for 3 or more branching layers. Likewise, if we look at the leaf, this is a single leaf. It's highly dissected, a compound leaf, which is also a strong characteristic of members of this family. Okay, not to belabor this because we did see a lot of them up the canyon, but here's another one. I'm not sure why the focus is so awful. But I did bring it home and took some pictures that removed the background. It kind of makes it a little bit simpler to see detail. You can see the umbellate inflorescence nicely. Again, this is a single multiply compound leaf with very, very fine ultimate segments to it. Okay, yet another. We saw this up the canyon. You can see the umbellate inflorescence nicely as well as the compound leaves. Here's a picture of it with a macro lens back at home a little bit later. Same with the leaf. This is one leaf, multiply compound leaf. So I don't think you're going to have any trouble with this. And just to remind you, we're never going to key these out. It's a kind of a complex family to key. And as I mentioned up the canyon, I believe we've got enough to do to learn how to use keys on things that are a little bit more straightforward. However, because this is such a common family and so easily recognized, this is going to fall within our Group B category of must-know families. So you will need to recognize it on site, but you won't need to know a floral formula, and we won't be keying this one out. So let's move on to something else. All right, remember bluebells from up the canyon. Let's see if we can figure this one out. First off, again, to give you a little information that's not readily obvious, this plant arises from a taproot, which tips us off immediately that this is probably a dicot. And of course, if you look at the number of floral parts, that's confirmed. This is a dicot. One of the things that you're going to need to know as we key this out is whether the leaves are opposite or alternate. And so this is a good opportunity to review this attribute if we haven't already done it in class, to give you a first exposure to it. This is where the yellow book comes in handy, and you'll want to have it by your side as you're keying, and the definitions and illustrations I'm going to show you come directly out of that. This just makes it a little more straightforward to work through on a video. So, alternate leaves, borne singly at each node as leaves on a stem. A node is the point of attachment of leaves on a stem. So if you look at the illustration on the right, you can see a node is labeled. It's just a position on the stem where the leaf arises. The space between nodes is referred to as the internode. Okay, opposite leaves, these are borne across from one another at the same node, as in a stem with 2 leaves per node. And you can see in the illustration, 2 leaves arise from the node opposite one another, the reason for the name. Likewise, up above for alternate, 1 per node, they usually alternate one side of the plant to the other. And that's where those names come from. All right, if we look back at our plant, it should be pretty clear. Are the leaves opposite or alternate? Well, if you look at a node, there's 1 leaf arising from it, and they do alternate. So this is a good alternate leaf arrangement. Okay, let's start building a floral formula now. And just quickly glancing at this, first from the top, you can see that there are 5 petals, and you can also see that those petals are united. By the way, notice the little white things. This has a narrow tube, so all of these petals narrow down to a tube. We'll get a better look at that in just a moment. But these white things in the throat of that tube are little glands that are very, very common. In fact, almost universal within this particular family. So it's a good field characteristic. If you ever have to identify one of these from a photograph, which you're likely to do as a quiz in this class, that's a good tip-off if you see these glands. They can be yellow, they can be white, but most of the time they are apparent in members of the family. Okay, from the side now, we know that there are 5 petals, and although we can't see it in this photograph because 2 are on the bottom side, there are also 5 sepals, and so we can put a superscript of 5 for the calyx and a superscript of 5 for the corolla, and since the petals are united, we're going to put a circle around that 5. So we're done with the perianth. All right, let's look at the reproductive whorls now, starting with the andrecium. This is a photograph. It's not the greatest. These flowers are tiny, 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 and I was doing this under a dissecting microscope, and I was having a horrible time trying to open this up and so that all of the stamens would be visible and at the same time snap a picture. And as you can see, I wasn't quite successful. A couple of them are hidden behind the curve of this thing. But there are 5 stamens, and they're arising from the corolla tube. They're actually attached to the corolla tube, which is also characteristic of this group, as well as others. So we can add our, down the lower right, A for andrecium and 5 stamens. This is 5 as a superscript. All right, let's look at the gynecium. I've pulled off the corolla. I've pulled off a couple of the sepals, and the stamens, of course, came with the corolla, so that we can look inside. And we have the same 2 questions to answer. Is this a superior or an inferior ovary? How many carpels are there in this pistil? Well, let's address the first question. Is this superior or inferior? I've labeled now the stigma, style, and ovary. And once again, the fact that you can see that ovary, we didn't have to rip any tissue off of it, it's not embedded in anything, tells us that this is a superior ovary. Furthermore, you can see that the calyx comes down and attaches below that ovary, and the corolla did as well before I removed it. So this is definitely a superior ovary. So we can add a G now to our floral formula for gynecium and a line below the G to indicate it's a superior ovary. Second question is how many carpels are there in the pistil? And this is a little tougher in this very, very young and very, very small flower. Remember the rule, we would start with styles, and there's only a single style, so we'd then go to stigma lobes. And these are slightly divided into 2 lobes, but I was not able to capture that well in the image. But this is composed of 2. This pistil is composed of 2 carpels. So we'll add a superscript. 2 with a circle around it to indicate those carpels are united into a single pistil. Once again, the ovary will develop into the fruit, but not for several weeks yet, and we have none to look at, so I'm just going to have to give you this. But it will develop into nutlets. This is not apparent in this very, very young flower, but the ovary, as it matures, will develop into 4 very distinct and prominent lobes, with the style arising out of the middle of those 4 lobes. And the fact that there are 4 lobes would suggest that there are 2 carpels, but in this case it's not true. There are only 2 locules, and they're mostly separated by a septum, but not completely. So there really only are 2 carpels in this thing. All right, we've got our floral formula complete. Let's start keying. One more time, we'll start right at the top. We won't do this in the future. If you recall from couplet 1, it had to do with whether there are flowers or not. And clearly this thing has flowers, so it's a member of the division Magnoliophyta. Let's go to 2. Flower parts mostly in 4s or 5s, leaves mostly net veined. Again, it's not real easy to see in the photos, but it does have a taproot system. Parts are definitely not in 3s or 6s. So this is in the class Magnoliopsida, which are the dicots. That's just a little bit lower on the same page. Class Magnoliopsida. Couplet 1, lead 1A says corolla and sometimes calyx lacking. Well, no, we had both a calyx and a corolla. So that takes us to number 2. Corolla of united petals, at least at the base. And these were united petals. So let's go to key B then. Key B is over a page or so. I don't remember the page number. Okay, this key B then will only deal with plants that have corollas of united petals. 1A, pistils 4 to 5. Well, that's not what we saw. We saw a single pistil, which is what's stated in 1B. So let's go on to 2. Ovary inferior or superior. We've already determined it's superior. That's why we have a line under the G. So let's go on to number 12. Stamens more than 5 or stamens 5 or less. Well, we had exactly 5. So we had 5 or less. So let's go on to 21. Plants lacking chlorophyll, not green, and if they lack chlorophyll, they'd be kind of a sickly yellow color typically. This is what we find in parasitic plants that aren't making their own food. But the leaves in this plant were clearly green. It does have chlorophyll. So let's go on to 23. Flowers irregular or regular. We've probably covered this already in class, I imagine, but this may not be a bad reminder. If we go to the yellow book, the definition of a regular flower is that it's radially symmetrical. Set of a flower in which all parts are similar in size and arrangement on the receptacle. Remember, the way that we determine this is, or symmetry, is we imagine a line drawn through the middle of the flower, and we look to see if it would form a mirror image on both sides. So now I've drawn a red line right down through the middle, and you can see that it does form a mirror image on both sides. And if we draw a different line in a different position, it also forms a mirror image, and yet again, still a mirror image. And so this is radial symmetry. We could draw as many lines as we wanted, and as long as that line passed through the middle of the flower, it would form a mirror image. In contrast, if we look down at irregular flowers, they're bilaterally symmetrical. So yeah, I can draw a line right through the middle vertically, and we do indeed have a mirror image on both sides, but that's the only line of symmetry that will form a mirror image. If I drew one there, for example, well, that's not a mirror image. The flower's parts are arranged a little differently on the left side than on the right side. So in this case, our flower definitely exhibits radial symmetry. And if you look at the flowers up close, there's one line of symmetry, there's another, yet another, and so on and so on. So if we go back to the key now, we definitely want to choose flowers regular, which is what's stated in 23b. That takes us to 27. Plants usually with milky juice. This is something else you can't see, but if you were to break a leaf off a plant and kind of squeeze it a little bit, some plants, the juice comes out milky. Think of a dandelion or a milkweed. But that's not true here. The juice is watery. And in addition, we only have one ovary. So let's go to 29. Ovary deeply four-lobed or not deeply four-lobed. Well, if you recall from the photographs we looked at, this ovary was not deeply four-lobed. But the only reason it's not is because it's too young. And if we were to look at this a little later in the season, it would clearly be deeply four-lobed. By the way, a little tip here, whenever you're looking for features of the ovary, especially in small flowers, if you have the option, look around for the oldest flower you can find, and preferably one that's withered up and the ovary is developing into a fruit, because now it will be much larger and you'll be able to see the mature characteristics much better. So let's go with deeply four-lobed. You'll just have to trust me on that. On 30, plants usually rough hairy, stamens 5. Ours wasn't especially hairy. This particular genus, is a little bit anomalous in that regard. Most members of this family are distinctly hairy, and by rough hairy it means to the point that if you grab them with your bare hand, sometimes it can actually jab you or be irritating. Not true with this plant, but we did see quite a few stiff hairs on the calyx, if you recall from the earlier photographs. And in any case, the stamens are 5 and the leaves are alternate. So we have our answer. This is the family Boraginaceae. And this is one of our Group A must-know families. So this is one that you'll want to learn to recognize on sight. The distinctive characteristics, they're kind of listed here, really. Parts in 5s, petals united, usually rough hairy, 4-lobed ovary almost always, and with the style arising up out of the middle of those. And then those little glands that I pointed out to you in the throat of the corolla tube is another good tip-off for this family. Anyway, you need to know the floral formula for this one and be able to recognize it on sight. Okay, we have one more to do. This one is not a member of our must-knows. It's not either in Group A or Group B. So this is not one that you need to be familiar with. These kinds of families that we sort of hit upon now and then, and you will too, by the way, in your own collections. I'm calling Group C, but you'll never have to recognize this on sight or know a floral formula for it. But it's a good opportunity to key out another plant. Notice that this is a really pretty thing. Notice how the stamens are, the term for this is exserted. They extend beyond the corolla and give it this really nice, delicate look. Here's a photograph with the macro lens back home again. You can see the details a little bit better when some of that confusing background is removed. This is a perennial plant, comes from tuberous roots. That will be important later, the fact that it has tuberous roots. All right, let's start building a floral formula. First thing, here's a picture of the flower from the underside with the flower stalk removed. You can see there are 5 petals, and they're united again. You can also see that there are 5 sepals as well. So we have both calyx and corolla in this case, and the petals are united. Technically, the sepals are probably united at the base too, but not distinctly so we won't worry too much about that. Okay, there's the first part of our floral formula then. Calyx with a 5 superscript for 5 sepals, corolla with 5 petals, circle around it to indicate those petals are united. So we're done with the perianth. Let's look inside now, and starting with the andrecium, look at the reproductive whorls. Pretty obviously 5 stamens in this case. So let's add that to our floral formula. A for andrecium with the superscript 5. And now we need to look at the gynoecium. I've labeled the ovary, drawn a line to it, and then notice the question in the upper left-hand corner. Is the ovary superior or inferior? And at this point, that should be very, very obvious. We can see the ovary, nothing's been ripped away from it to see it. And as you can see, even from this photograph that doesn't provide a ton of detail, you can see that the other parts arise below it. I'm going to show you one additional picture that may be helpful here. Now I've labeled the style and stigma as well, and you can see the ovary. And you can see that all of the parts are arising below. So this is definitely a superior ovary again. So we'll add a G for gynoecium with an underline to indicate a superior ovary. Now we need to know, and the question's posed up in the upper left, what's the carpel number? Well, keep our rules in mind. Start with the style. There's only one of those. But look at the stigma branches, and there are clearly 2 of those. We're done. As soon as we see that, we know there are 2 carpels that make up this pistil. So we'll add a 2 as a superscript, circle around it indicating they're united, fused together into a single pistil. Once again, we have no fruit, so I'm just going to provide you with that, but the fruit type in this plant will be a capsule once it matures. All right, now that we have our floral formula, let's start keying. And based on what we've seen, we know that this is a dicot, don't we? So we're just going to skip this first part, and we'll go straight to the class Magnolia Opsida, which is what you're typically going to do as well. You'll start recognizing dicots right off the bat. Corolla and sometimes calyx lacking. No, corolla and calyx both present. So let's go to 2. Corolla was composed of united petals, so let's go to key B again. Pistils 4 or 5 or pistils 1. Well, we only saw single pistil, so let's go to 2. We already determined that this is a superior ovary, so we'll take 2B, which leads us on to number 12. Stamens more than 5, stamens 5 or less. We had exactly 5, so 5 or less is the correct statement. We'll go to 21. This is a familiar part of the key. We just were through the same section of it. Plants lacking chlorophyll? No, we have good green leaves. So let's go to 23. The flowers regular or irregular? Well, these are regular flowers again. You can see that even from this slightly tilted image, and especially from the calyx. And the calyx and corolla are usually going to be similar in that regard. So regular flower. That takes us to 27. Plants usually with milky juice. No, this doesn't have milky juice, and we have a single ovary. So the second lead is a better choice. Down to 29, ovary deeply four-lobed or not deeply four-lobed. Well, it didn't look deeply four-lobed, and in this case it won't become four-lobed either. So we're going to take the second lead and go to 31. Not a woody plant, it's not a tree or a shrub, it's a herbaceous plant, so we'll go to 33. Stems twining or prostrate. Twining would mean that it wraps around things. It would be a climbing vine of some sort. Prostrate would mean it would lie flat on the ground, it wouldn't stand upright. And neither of those are true of our plants. So we're going to take the second lead and go on to 34. Corolla small, 2 millimeters or less, and colorless. Well, first off, our corollas were probably 10 or 15 millimeters long, and they certainly did have color. So they're not as above. 35, ovary 1 loculed or 2 to 5 loculed. And in this case, there are 2 locules, so, and you kind of get a hint of that. It's too small to actually cut. But it's a pretty good bet. It's not a guarantee. Oh, I'm sorry. You know what? I'm leading you astray here. Even though this thing had 2 stigma lobes, it only has 1 locule. So probably it would have 2 placentae within that single locule. Anyway, we need to go to 36. Stamens opposite the corolla lobes or alternate with the corolla lobes. At this point, I don't know whether you've been exposed to this or not, so let's go through it real quickly. Opposite stamens, borne over or on the same radius as other organs rather than between them, as a stamen in front of a petal. Notice how the stamens and the petals line up with one another. In other words, the stamen is borne on the same radius over the petal. And if you look at alternate stamens, in this case, they're borne between other organs, in this case, stamens between the petals. And if we look now at our flower, by the way, I should say this is not always an easy thing to see. Sometimes those stamens get kind of floppy and wobbly, and you're not entirely sure whether they line up with the petals or are in between them. And if you ever have to guess, if you're never sure, or if you ever come to a plant you're not sure, always choose alternate arrangement of stamens because it's far, far more common. And if you look at this photograph, you can see pretty clearly that those stamens are arising between the petals, not directly lined up with them. So this is an alternate arrangement. So back to 36, stamens alternate with the corolla lobes takes us to 38. Seeds, well, way too young to look at seeds. But if we look at the second part of this, petals actually petaloid sepals, well, that's not true. We had a good calyx whorl and we had a good corolla whorl. So those petals really are petals. So true petals are present, as stated in 38b. So we go to 39. Plants usually glabrous, and this is something, if we were actually out in the field doing this, I'd make you all pull out your yellow book and look terms up. That's a general rule. If you don't know a term, look it up. Don't take a guess. You're bound to be led astray if you do. So be patient and systematic and do look up words. However, I'm going to give you this one. Glabrous means that it's not hairy. And the inflorescence not scorpioid. The alternative says plants usually hairy, inflorescence usually scorpioid. This plant is not particularly hairy, honestly, but you may recall when we were looking at the calyx a moment ago, it was quite hairy. And many members of this family are very, very hairy. Inflorescence usually scorpioid. We're kind of striking out here a little bit. Here's an illustration of a scorpioid. It's kind of a schematic drawing of one from the yellow book. But it means that the inflorescence is kind of curved like the tail of a scorpion, as you can see here. And that's not apparent from in our plant. It's very, very mildly scorpioid. And notice the wiggle words in 39b. Plants usually hairy, inflorescence usually scorpioid. This one's not clearly either of those, but it is our best choice. So this is a member of the Hydrophyllaceae. As I said, not one of our must-know families, so don't worry about memorizing floral formula or anything like that. But let's go on. Let's see if we know the family now. Let's go to our little spiral-bound book to the Hydrophyllaceae, and we'll work from there. So remember, families are alphabetical, and this is a dicot, so more of the forward part of the book. Okay, first, flowers solitary or flowers in cymes or ball-like clusters. I'm sorry, there we go. Flowers solitary or in ball-like clusters. You probably recall these were in clusters. In fact, they were quite ball-like. These are said to be capitate clusters. Capitate meaning ball or head. So let's go on to number 3. Stigma terminated by a minute ball, plants with tuberous roots. I'll tell you, I spent a lot of time trying to get a good image of the little minute balls at the tips of the stigmas on this plant. And they're so incredibly small. I could kind of make them out under the scope, but I never was able to get a good picture of them. But we do know that the plant comes from tuberous roots. So this is the genus Hydrophyllum. And so we know the family now, we know the genus. Drop down, genera, remember, alphabetical within the family. So drop down, still on the same page, to Hydrophyllum. We only have 2 choices. Flower clusters on peduncles. Peduncle is the stalk of the entire inflorescence, the entire bunch of flowers. So flower clusters on peduncles that are much longer than the leaves, or flower clusters on peduncles that are distinctly shorter than the leaves. Well, take a look at this plant. You can't really see real well from here, but it doesn't look like the peduncle is terribly long. And in fact, it's not. They're much, much shorter. In fact, here's a picture that shows that a little bit more clearly. And you can see the leaves are way, way longer than the stalk of the inflorescence. So what that means is we take the second choice. This is Hydrophyllum capitatum. In this case, you're even provided with a variety name, although that isn't too important for our purposes. Anyway, a real common spring blooming plant in the Wasatch Mountains and, of course, elsewhere as well. All right, that finishes our Santaquin Canyon field trip. I hope this has been of value to you. To be quite honest with you, doing it this way allows us to be a little bit more systematic as we work through the keying. And I'm hoping I'm able to give you some images that are somewhat clear, especially of small flowers, of things that would be difficult to look at even with a loupe, with a hand lens out in the field. So this is kind of what these field trips are going to look like. In the future, we'll probably have some quizzes that follow field trips. As you become introduced to our must-know families in class and we have a chance to see them in the field, I'll start giving you periodic quizzes where you'll have images of the distinctive attributes of the plant. You'll have to tell me what family it belonged to. Also, we will do some collective keying on future field trips again, but not nearly as much as this time. Now that you know how to use keys, you know how to use the yellow book, you've sort of been walked through it a few times, I'm going to leave a lot of that to you in the future. So some of our future field trips may be a little bit shorter. All right, we'll see you next time.